Let's go ahead and now you write this down. Inside of our atom is broken down into energy levels. And those are going to be 1 through 7. It corresponds to the rows on the periodic table as you saw in your reading from yesterday. Within an energy level, we have a sub-level, and those are going to be the letters that you saw yesterday: S, P, D, F. And then within that sub-level, there's that three-dimensional electron cloud, which we call an orbital. It's a 3D shape. This is also known as your electron cloud. So that's the organization of our atom. Inside the atom are energy levels. There's 7 of them. Within each one of those energy levels, there are sub-levels labeled S, P, D, and F. And then inside of each sub-level, you're going to have orbitals. And the electrons live inside the orbitals. We'll make a little note to ourselves. Electrons live inside orbitals, an orbital. Okay. So for our analogy, Virginia Beach would be our atom. Your neighborhood would be your sublevel. Your street would be your sublevel. And then your actual house number would be your orbital. Okay, so I'll say that again. Virginia Beach is like your atom. Your neighborhood is like your energy level. Your actual street is your sublevel. And then your actual house number, where you live, that's like your orbital, okay, if you were an electron. So we're going to have to draw a makeshift periodic table here. We're not going to draw all the boxes. It's going to look like this. So you might want to see what it looks like first before you attempt to draw yours. I'll put this down. Drawing like a modified periodic table. This is helium. Down. Then underneath, we're going to have those 2 rows that we usually take out. Okay. So we're going to divide this up. On the left-hand side of my makeshift periodic table, I'm going to draw 2 columns. On the right-hand side of my makeshift periodic table, I'm going to have to draw 6 columns. 2, 3, 4. Uh-oh. 6. Told you it's not going to be pretty. That's what we're going for. 2 columns on the left, 6 columns on the right. I know it's not drawn to proportion. Okay. So if you have any colored pencils or markers or colored pens or highlighters, um, let's go grab them, okay? Because we're gonna break this into four main sections on our periodic table. So I'll give you a few seconds. If you need to step away and go get some colored writing utensils, go ahead. I'm gonna grab mine. Because it'll be helpful, at least if we can outline some of these main sections. So go grab colored pencil, crayons, whatever you got, markers, a highlighter works, a colored pen even works. Okay, we're gonna label this section, these first two columns, with a lowercase s. And we're gonna draw the shape of an s orbital. An s, think of the word sphere. As you saw yesterday in those Google slides, the s orbitals are a sphere, okay, big circle, three-dimensional circle. Okay. Also, with that same color that you chose, please put a box around helium's location, top right-hand corner of the periodic table. And we're also going to label that as a lowercase s as well. Okay, so I have the two columns on the left, S, and then helium spot S as well. So helium's location is really part of this S region. Okay. Grab another color, different color. I'm going to use blue for mine. Those 6 columns that we made on the right-hand side, I'm going to outline those 6 columns in that new color. So make this a little bit thicker. There you go. So I'm choosing blue for mine. You can choose whatever color you want. Important thing is that we are showing the difference between these sections on the periodic table. All right, not the prettiest, Miss Wong, but it's all good. It will work. All right. So the important thing is that we have 6 columns, and they're on the right-hand side of that periodic table. Now we also have to write a letter for this. It is a lowercase p, as in Peter. A lowercase p. Now, I think back to what I saw yesterday in that Google slide and that exit ticket from yesterday. The P shapes, they are called dumbbells. I think they look like infinity signs. It's like an elongated number 8. Okay, so for P, but I'm going to draw that, but I'm going to draw 3 copies of them. So I'm going to draw that's my dumbbell shape. There's one. Laying horizontal. Then I'm going to draw one standing up. This. Okay, there's another p orbital. And then I'm going to draw one diagonal. Okay, so for these 6 columns on the right, that's known as the p block. The shape of p orbitals are called dumbbells, or they look like infinity signs. And there's 3 copies of them. One laying flat, flat on your paper, one standing up, and then one kind of going through your paper, okay, at an angle. I know all of this sounds strange, but trust me, it will make sense in a few minutes. Grab another color if you have it. I'm going to choose green. This middle section, I'm going to outline in green. So there's a few things we have to write inside of this middle section. This is where our transition metals would be on the periodic table. First thing I want you to write in the top left-hand corner of this section, please write 3D, and that's all lowercase d. You're gonna write 3D in the top left-hand corner. And what this means, we're gonna make ourselves a note. D is one less E level, E standing for energy, than S. D is one less energy level than S. We also need to label this section as we did with the other ones. So I'm going to write a lowercase d. And then the shape of the D block, they look like four-leaf clovers, as we saw in yesterday's assignment. We're not going to draw the four-leaf clovers. We're just going to write that they look like four-leaf clovers. They have a four-leaf clover shape. Four-leaf clover shape. All right, and then one last section are those two like rows at the bottom called your inner transition metals. Those are the two rows, the section of elements that we've kind of taken out of the transition metals. We call them the inner transition metals. You can label, you can draw another box around them if you want to with a different color. I'm gonna choose purple. If you're out of colors, that's okay. This one's not too important. We don't, at this level of chemistry, we don't deal too often with this section down here, but we still have to know what it's called. In the top left-hand corner, just as we did with the D block, we're gonna have to write number with a letter. So please write 4F in the top left-hand corner of this section. And we're going to label this with a lowercase f. And the shape is very complex. We're not even going to attempt to draw the shape of what the F orbitals look like at this level. Just know that they are very complex. Some might even call them funky, because they're the F block. All right, so there's my overview of the periodic table. And you're like, oh my gosh, what are you talking about, Ms. Wong? Trust me, it will all make sense. There's a few more things I want us to label. Okay, so now again with your pencil, we're going to make ourselves a note here off to the side that the row number equals E level. Okay, and when I write a capital E is the abbreviation for energy. And you're welcome to use that in your notes and in your responses to me. It is common scientific language. When we write a capital E, we all know that you're saying energy. When you write a lowercase e, that means electron. So capital versus lowercase e does make a difference. So if you're using abbreviations like this, just be mindful of making sure you're using the right ones. Okay. And then one other little note I have to make to myself. It's pretty important here. We're going to draw an arrow and we're going to point towards where hydrogen would be on that periodic table. And you're going to label that start. All right, so I'm going to zoom out here, recap where we're at so far. We know that the atom contains electrons. Those electrons are in a particular energy level. But within that energy level, they live inside a sublevel. But within that sublevel, they live in a three-dimensional shape called an orbital. And this makeshift periodic table that we've drawn is going to help us determine the location of those electrons inside of an atom. And so we're going to be writing these